Okay, so I think this is going to be good enough, hopefully, to see. Okay, let's do 5.5, right? No questions on 5.4?
I don't think so.
All right. What is 5.5? Who gets the extra credit for jumping ahead?
I did not jump ahead. I apologize.
Okay, solve this, guys.
Okay, I got this. Help me on this one.
So I have some hints over there.
Yeah, I wrote those down as problems.
I know, and I left like a bunch of space in it. I was like.
No, these are double angle formulas. So daft.
Shut up.
Double angle formulas over there. Okay. So you've got the sheet here as well.
Wait, like the cosine 2 you think is that the same as like 2 cosine x?
No.
It's not.
No. So cosine of 2x is actually equal to, or sorry, well, sine of 2x in this case is 2 sine of x cosine of x.
Oh, okay.
So that's why we have the double angle.
So it
formulas.
does matter where like the 2 is.
Yes.
Okay.
Yep. So this would be 2 cosine x plus, well, sine of 2x, look over there,
Yeah.
2 sine x cosine x, right? And that's equal to 0. And so 2 cosine x, 2 cosine, I'm going to factor out I'm going to divide everything by 2, right? Goes away. And I'm left with cosine x plus sine x cosine x. So I'm going to factor out the cosine x, right?
Wait, I did not help on this one.
Then don't pay attention.
Well,
Okay, so I'll leave it there. Ella,
Yeah.
what do you got?
I have no idea. I'm trying to figure it out.
Natalie's got it.
well, I have to plug in my
So what do you got, Natalie?
cosine x equals 0 and then sine x equals -1.
Yes.
Oh.
Correct. Right, or 1 plus sine x equals 0, or
Yeah.
cosine x equals 0, right? So you set this equal to 0, this is just like x
So we're
times,
just like finding zeros.
yeah, so this is like x times x squared plus x equals 0. I factor out the x, so I get x times x plus 1 equals 0. Therefore, x equals 0 or x plus 1 equals 0, right? Just algebra there. Same thing. Except now I do a little trig. I say, what is x here? If cosine of x equals 0, x equals, where does x equal 0? Where does cosine of x equal 0? Yeah. Right, so vertically up, vertically down.
Why is it cosine x times 1 plus sine x squared?
So I factored out the cosine x here, and I'm left with 1 and sine x, right? Factor that out, okay? And so then if I get the cosine x times 1 plus sine x equals 0, one of those two terms has to be 0, right? And so either that's 0 or that's 0. Well, that's 0 when x is pi over 2 and 3 pi over 2. This is sine of x is -1 and x is 3 pi over 2. Very good. At, was it at Ella underscore?
I was outside
Sykes.
That's my Insta.
Okay. Very good. All right, so here, these are the same thing, right? So I don't need that, obviously. But then you can double check, say pi over 2. So cosine of pi over 2 is 0, so 0, plus sine of pi over 2 times 2, which is pi, which is 0. 0 plus 0 is 0, check, right? And 3 pi over 2, cosine of 3 pi over 2 is 0. Sine of 2 times 3 pi over 2 is 3 pi, so sine of 3 pi is 0, 0. They both work, right? And they should both work. I didn't do any manipulation of it. I didn't square it, right? Which is usually that's where I run into the duplications that don't actually solve the original equation if I squared it. Okay? All right. And I've got to rewrite this into a double angle formula. Okay? So rewrite y equals 4 cosine squared x minus 2.
You want us to do what with it?
So I want to rewrite this into a double angle formula, right? So I get y equals, factor out that 2. That's the first and easiest thing, right?
Oh, then you already have one of them. Sort of. If you divide the whole thing by 2, right? Well, if you get rid of the outside 2 is 2 cosine squared x minus 1 already one of the double angle formulas?
Not.
I have it written down as one of them.
Which one?
For cosine, it's like cosine 2a equals cosine squared a minus sine squared a, but then it also can be the same as 2 cosine squared a minus 1, or 1 minus 2 sine squared a.
Yeah, I think so. So, because going the long way around, 2 cosine squared. So what was your final answer?
Well, I was just saying what's in the parentheses is already at double angles, so you just have to get rid of the 2 on the outside somehow.
Okay. Let's see. Going the full. So it's not explicitly in what I had right there, right? But yeah. So your answer was
2 cosine a.
2
or
cosine.
x minus 1. I'm more asking, because what's
Okay.
in there is already a double angles formula, so what do you do with the 2?
Well, not a double angle formula. This is just cosine squared x. So I need a cosine of 2x. I'm trying to get it into a cosine or a sine of 2x. Like these. So here I've got cosine of 2u is 1 minus 2 sine squared u. Right? So here, let me express the 1 as, what is 1? Cosine squared x plus sine squared x, right? So then simplifying, this is going to be 2 times 2 cosine squared x minus 1 cosine squared x is cosine squared x minus sine squared x, which is cosine squared x minus sine squared x is cosine of 2x, right? So according to the formulas I have written up there. So that's what we're trying to get to. It's taking this, breaking it down, factoring out what you can, and then taking what you have left and trying to manipulate it into using algebraic substitution or trait substitution here, right? And then a little bit of algebra, like simplification, and then getting into the form of one of the double angle formulas that we have available to us, right?
would it work if, because you did have, or I guess, if you were to like ignore the 2 on like the second step there, you could just have like cosine squared x and then turn that into cosine 2x minus, or plus sine squared x, does that work?
Yeah, so here, like,
Yeah, you're just to ignore the
cosine
2%.
squared, yeah, cosine squared, this would be what? 1 minus sine squared x, right?
Yeah.
Yeah, and then you could substitute that in there, and then I would get 2 minus 2 sine squared x minus 1. Right, you could probably, you could do it that way, right? 2.
Okay.
So what would you be left with? 2, well, you'd be left with 1, so 1 minus sine squared x, which is 1 minus 2 sine squared, or yeah, we'd have 1 minus 2 sine squared x, which is, yeah, same thing, right? You could do it that way too.
Okay.
Right. Sorry, Natalie, was that?
Well, okay, no, so what I figured out what I was doing wrong is I thought it was solved, but we were trying to find what of the y, like which one y was, but we could have just figured it out at the first step with the 2 cosine squared x minus 1. That is a cosine 2a. That's a form of cosine 2a. So we could have just plugged it in there instead of doing the extra steps. So I was wrong with what I was saying, but like we could have solved it farther up.
Solved it further up?
Yeah, for the 2, when we have it 2 and then in parentheses 2 cosine squared x minus 1, that's one of the functions of cosine 2a. So we could have just plugged it in there. It's not up there, but I have it from last year on
Oh,
the
okay.
sheet, so
From,
it's like,
from a different, yeah, so you've solved it out already.
sort of, yeah.
Yeah, okay, I gotcha. Yeah, so if you have that solved, I mean, I could take this and I could rewrite this in different ways, right? So sine squared u is actually 1 minus cosine squared u, so this would be 1 minus 2 times 1 minus cosine squared u, which would be 1 minus 2 minus plus 2 cosine squared u, which is 2 cosine squared u minus 1. 2 cosine squared u minus 1. There you go. Yeah. So, okay, I got what you're saying. I was just going from what I had written up there. You see that, in fact, yes, what she was saying, I wasn't quite understanding what she was saying, but yeah. So if you've written these out in multiple patterns, then you could go there. Yeah. Okay. And actually what Cameron was saying is going here and going a different step and rewriting cosine squared x as 1 minus sine squared x. That gets you there too. Right? Either way, you would end up with cosine of 2x. Okay. Number 21. Or how about 22?
I was upset.
So find that as a double angle. That was actually pretty easy, right?
Oh wait, is that what I was watching?
You guys get that into a double angle formula?
Hold on. Does the thing at the top matter at all?
Nope.
Okay.
No, just left over from the last one.
Can you just multiply across?
Foil it out.
Yeah.
Minus cosine sine plus cosine sine, so they cancel out, right?
Yeah. Sine squared. It's
What is that?
well minus 2 squared 1. Wait a minute.
It turns into cosine.
Minus, minus, not plus, right?
Oh, dang.
Cosine 2x, yeah. There you go, all done.
We did that.
Huh?
How'd we get that? Look, so if you look at your double angles thing,
Yeah.
cosine squared a
Right there.
minus sine squared x it's equal to cosine 2. Are those not on? Yeah. Let me see it. Yeah, they are. They're right here. Cosine 2x. Done. 2x. We should just
Do you have formulas?
All right, any questions on that? So, again, obviously you see something like this, you FOIL it out. Immediately, it becomes part of my formula sheet, right? It becomes something on the formula sheet, okay? All right, so let's go back to a solving one. Solve this equation here for x. So, tangent of 2x right there, right? Do tangent x1 and over 1 minus tangent squared x. Okay? So this, according to my formula sheet, is this, right? So here I'm just going this way. So okay. What's the next step?
Isn't it just equal tan 2x? Is that what we're trying to solve right now?
Oh, well, here we're solving for x, right?
Oh, okay.
So I divide by 2, maybe? Get rid of the 2.
Do you multiply by the
Positive version.
Just kidding.
What is, no, plus tangent squared x, so that doesn't work. Tangent squared x is secant squared x minus 1. No, I don't like that either. So, how about I multiply over, do I want to do that?
Would you have to move the cosine over if you multiplied by the 1 minus tan? Blah, 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 blah.
Tangent x, if I cosine, sine over cosine, if I get a common denominator, what if I do a common denominator? 1 minus, I multiply by 1 minus tangent squared x over 1 minus tangent squared x. And then I have a common denominator, right? And I can take my top. Does that help at all? So then I'm just left with tangent x minus, and if I
Cosine x minus
cosine x,
2x.
right? And because my denominator doesn't matter, right? I just multiply both sides by my common denominator, right? Which actually I could have done in the first. Multiplied everything by 1 minus tangent squared x, right? To get rid of my denominator altogether. Which is essentially what I did there. Just multiply everything by 1 minus tangent squared x. So if I just totally ignore what I did there, okay, So if I do this, cancels that out, and then I'm just 1 minus tangent squared x times cosine x, right? And that's equal to 0. It's just still equal to 0. Now what do I have? So now I have tangent x minus cosine of x, and then plus cosine x tangent squared x. But what is tangent squared x?
Sine over cosine.
Sine squared x over cosine squared x, right? So I can get rid of that, and then what am I left with? Sine x over sine x minus, and then if I get a common denominator, cosine x, this is cosine x over cosine x, right? I turn this into common denominator again. Sine x minus cosine squared x plus sine squared x over cosine x. And then I just multiply everything by cosine x again, right? I get sine x minus cosine squared x sine x. Right, so this is, am I making this too complicated? I think I'm making it too complicated. Cosine squared. Take tangent x